What I'd like to do now is to run through the background of how we get the sine graph and how we get the cos graph. So if we go back to our knowledge of, we get this pen to write, the unit circle, our good old friend the unit circle. It's called the unit circle because it has a radius of 1. And if we start here and we go in this direction, we know that is the positive direction, and we can make out an angle of theta. So this point here will have the coordinates of x and y, and we drop a perpendicular down there, and so this is my x and this is my y. So this is a radius of 1, so we know that the sine of theta, which is opposite over hypotenuse, is y over 1, which is just equal to the y coordinate. And we know that this is regarded as 0 degrees. This is up here, let's say work in degrees, so we got 90 degrees up there, and that's got a coordinate of 0, 1. This is 180, and that's got a coordinate of -1, 0, and this is 270. And it has a coordinate of 0, -1, and we get back here to 360, and it has a coordinate of 10. Okay, and we know that the sine is just the y, the sine of theta is just the y coordinate. Okay, so let's transfer all our knowledge of the unit circle onto an xy graph. And we'll sort of line it up with this one here because we're going to link the two together. Okay, so here's my 0. Let's go up 90, 180, 270, and 360. Okay, so the sine here is 0 degrees, so don't forget this point we'll call P. If it's point P is here, theta would be 0 and the y coordinate is 0. So what we're going to do is we're going to graph sine x versus x. Okay, so we could say y equals sine x, if you like, is going to be our graph. So this is going to be the graph of sine. So going back to here, that's 0 degrees and the y coordinate is 0. So there's a point on my graph. If we go to 90, point P is moved around to here. There's 90 degrees and the y coordinate is 1. So at 90, let's just put up here to 1, that's -1. So at 90 degrees, that point there is going to be on the graph. We keep going around the unit circle and we get around to here, and we're at 180 degrees, which corresponds to over here on my graph. And 180 degrees, the y coordinate is 0, so we're back down to there. We know that sine is positive in this quadrant and that quadrant, and if you look at our graph, it is going up here where sine is positive, the y is positive on the top side of the x-axis here. Okay, let's continue on. So we go around to here, the y coordinate is -1, so we're down to there, and then we're back in to 360, which is the sine is the y coordinate, and the y coordinate there is 0. There are intermediate ones, and you could put in 30, 60, then 120, 150, etc., and you'll get intermediate values. Not straight lines, they are curves. So we go, let's use another colour, We'll add a bit of colour to our life. So, okay, we'll do that. We'll do it in red. And so we go up, down, and it comes down there. So then sort of almost got that one over there, but anyway, you get the idea what's going on. So that's between 0 and 360, and we've already seen that if we get to 360 and keep going, then values repeat themselves. So we're virtually back here on the graph, so the rest of the graph would carry on exactly the same as what we've just done. All right, now that's going in the positive direction, so as x is getting bigger. If we go this direction, down here, this is the negative direction. So these are negative angles. So we just write negative 90, negative 180, negative 270, and we're not going to quite fit it in, but you'll get the idea of what's going on, and negative 360 is going to be just about there. So if we go this direction, so go back to here, that's negative 90. Going back from there to there is negative 90 degrees. The y coordinate there is negative 1, so we're going to put this point. If we go all the way back to there, that's negative 180, so that's up to there. Negative 270 is up there, and in the forest over there we've got negative 360. So we continue our graph, and we get that. All right, so that is y equals sine x, and it continues. So we can put arrows on the end to show that it just keeps on going. It does not stop. From that, if we drew it accurately enough, given any number of degrees, we can go up and across, and we would find what the sine of that angle was. So we've related the unit circle to the actual sine graph. We can see that the domain of sine x, y equals sine x, well, x can have any value, so from minus infinity up to infinity, and the range, very important, that the y equals sine x can never be greater than 1. It can be equal to 1 at that point, and at that point it is equal to 1, and it can't ever be less than negative 1. So we've got negative 1 less than or equal to y, because it can be equal to negative 1, and also it can be equal to 1. So there's domain and range. So we've actually linked the unit circle back to the sine graph. Note also that from here, let's do it in another colour again. So from there to there is what we call one period, because this is the part of the graph that if we could actually cut from there to there and pick that up and move it over to the left here, we could just plonk it down and it would be exactly the same. If we wanted to pick this between 0 and 360 up, cut it out and plonk it from 360 to 720, it would be exactly the same. So when a graph is repeated, a sectional graph is repeated over and over again, we call that exactly one period, and that is the length from there to there. In this case, the period is 360 degrees. The amplitude is half the distance from a peak to a trough. Now, there's a peak, so +1 is where the peak is, and the trough is located at -1. So half that distance is the amplitude. So amplitude is equal to half the distance from a peak to a trough. There's my peak, there's my trough. It's the vertical distance, not the straight line distance, so it's half of that. Now that goes from +1 to -1, so that will have an amplitude of 1, because the distance from peak to a trough, the vertical distance is 2, and half of that is equal to 1. Okay, so that's the y equals sine x. Let's do the same thing with y equals cos x. So we'll draw a unit circle. And once again, we've got y and x. X, don't forget, is just to there. And y is from there to there. And we know that cos of theta, this is 1 because it's a unit circle, cos of theta is adjacent over hypotenuse, is just the x coordinate. And then if we want to put these coordinates on here again, we've got 1, 0, and that's at 0. So what we might do is, instead of using degrees, we'll use radians for this. So this is 0 degrees, or if you do 1 complete revolution, or 0 radians and 2 pi radians. Up here, well, let's do this one over here first, because sometimes that's the easier way. So if it's 2 pi all the way around, well, it's pi over here, and that will have the coordinate of -1, 0. Halfway between 0 and pi is pi on 2, so that's the angle up there. Pi on 2 is 90 degrees, and the coordinates up here are 0 and 1. This is halfway from pi to 2 pi, so it's 1.5 pi, which is 3 on 2 pi. 3 on 2 is 1.5, which is halfway between pi and 2 pi, and that is 0 and -1. Okay, now the important thing to remember in this situation is that the cos of the angle is equal to the x coordinate. So let's draw our xy. So we've got 0, so we're going to go pi on 2, pi, 3 pi on 2, and 2 pi. Now, this is a unit circle, and so the top of the graph will correspond to 1, and the bottom of the graph, well, we're a bit out of skew here. This graph should have came down a bit. Anyway, we'll put -1 down there, so we've got equally spaced top and bottom. So corresponding on the unit circle, and the unit circle would have come down a bit lower. Okay, so at 0, this point here, cos is equal to the x coordinate, and the x coordinate at 0 is 1. So our graph is going to actually, the cos graph is going to start up there. By the time we get up there, at pi on 2, which is over here on my xy graph, up here the x coordinate is 0, so we're down to there. When I get to pi, the x coordinate is -1, corresponds down there. 3 pi on 2, x coordinate is 0, and at 2 pi, which is 1 complete revolution, the x coordinate is back to 1 again, so it's there. So we can draw those with a similar shaped, sort of similar roundedness. So just think of this as sort of coming up. Don't sort of start going straight up. Go along a little bit first before you drop down. They are sort of rounded turns. That's not too bad, actually. So there's my y equals cos x between 0 and 2 pi. Once again, that is 1 period, because I can pick that piece of the graph up and put it over here. But just to show you how it works, let's go back negative pi on 2, negative pi, negative 3 pi on 2, and once again we're in the jungle over here, negative 2 pi is way over here on my xy graph. And if I was to plot the points, I would be going at negative pi is when you go in this direction and you're back to there, and the x coordinate is 0, so we're there, 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 and up here. So that'll get us out of the jungle. So we go down, up, and over there. So that's, if you like, 2 periods of the cos graph. The amplitude half the distance from a peak to a trough. So that's 2 from top to bottom, so half of that is equal to 1. The period is equal to 2 pi. Up here the period was equal to 360, and as you know 360 degrees is exactly the same as 2 pi radians. It also corresponds, if you have a look at this graph here, we said we know from our CAST, so CAST on the unit circle tells us which trig ratios are positive, and this says here, if we go back and look at this unit circle again, that cos is positive in the first quadrant. Now in the first quadrant it's between 0 and 90, and we go over here, here is between 0 and 90, so from there to there is between 0 and 90, or 0 and pi and 2 in radians. And you can see that all the cos values are positive. This is where it's positive, down here is where it's negative. We then do 2 quadrants of negative, and that corresponds to these two, from here to here and here to here. From pi and 2 to pi, pi to 3 pi and 2, you can see that cos is negative there. And then we come back into the 4th quadrant where cos is positive again, and that corresponds to this section here. And you can see that cos is positive. So hopefully this has tied together the unit circle and the sine and cos functions.